Hello everyone, I'm Dr. Manoj Tripadi. Today I'll be presenting you the concepts of software agent, which is a mix of uh, artificial intelligence as well as the software engineering concepts. It's a first year course of MTech program dealing with the aspects of intelligent agents and mix of artificial intelligence in the programming part. First of all, let's focus on what is the basic idea or what we can say is what is agent. An agent in a simple language is defined as an autonomous body acting independently and exhibiting control over their internal state. Means what? Autonomous here means that they have the capability of thinking and taking their decisions on their own, right? They cannot take, they can take their own decisions as and when the situation arises, right? We can see from the slide that agent is a computer system capable of autonomous action in some environment in order to achieve the objectives, or you can say the goals. So it is the environment which are providing the input to the agents, and based on these inputs the agent is performing some type of activity and giving them the necessary output, right? That is the basic idea of simple agents. Now, for example, a trivial agent, or we can say a very small agent, we can say of an iron, or you can say a press, where we have a simple machine known as thermostat. Its function is as the temperature increases, the bimetallic strip turns its shape and deviates from the main point, as then it's turn off the press, and it will turn on and off depending on the temperature which we have set, right? So it's a very small type of agent which doesn't have the capability of a thinking part, but it can perform its own capabilities. And the specific capability here is to maintain the temperature of press, or you can say the iron, right? While as intelligent agent is a different set. It is a computer capable, flexible, autonomous action in some environment. By the word flexible, I here means that it is dealing with some intelligence which is close to human being, and it has the capability of reactive, proactive, and social. By the word reactive here, I mean that the reactive means as and when the situation arises, it will take its necessary decision and react accordingly, right? While as proactive agents are those agents which will be determining the situation beforehand, or taking the decision beforehand before the actual occurrence of the event. They are pre-active, means they become aware of the situation which is just going to come. For example, if there is a storm which is going to come, then what it will show? It will be showing that how the storm has arrived to a particular location, right? And what are the necessary steps in order to prevent, minimize the loss of the property as well as human beings. So it will be giving the warning beforehand. That is known as proactive agents, and performing certain set of activities beforehand. While as the last step here is social agents. The social agents are nothing but a collaborative set of agents which as and when behave like human beings in a social gathering, and they communicate each other with a common language known as FIPA protocol, or a protocol type of language or a set of language in which each of the agents in and around will understand each other and do the work in a synergic mode or in a holistic manner, such that the overall goal of the organization or for which they are designed is being achieved, right? Here we are going to see what is the meaning of reactivity. Reactivity means that it's an ongoing interaction continuous type of reaction where the change is occurring in the environment, and based on the change which is occurring in the environment, it is dynamically changing at the back end. For example, if there's a storm, right? If there's a storm and I have designed my windows to automatically close based on certain wind condition or cyclonic condition, then as soon as the velocity of the wind is increasing in a real time situation, it will keep on increasing, and then finally it will close the window as I have programmed it for. If it is above certain situation, then it will close it. If it is below, it will not close my windows. That is known as reactive. As the situation arises, do perform certain things, but wait for the situation to arrive. They cannot do on its own, on their own, right? While as proactive is just the opposite of it. They prenumerate that this thing is going for, this thing is going to come in a near future, and based on that they will initiate certain action. If they judge that 50 kilometers down the side there is a storm which is approaching towards my city, then they will automatically close my windows, right? Thinking that the wind is traveling at 40 kilometers per hour. Now it will increase to 60 kilometers per hour. And by the time it reaches my home, it may touch 80 kilometers per hour. So it is better to beforehand close the particular window, right? It recognizes the opportunity on its own and then act accordingly. While as the social agents are nothing but it's a real world multi-agent environment where the goal is to, without contradicting each other's goal, the goal is to achieve the overall objective of the organization. Like we are all working in certain organization. And if we cut down each other goal, then we are not able to achieve anything. Neither the organization will grow. So it is only possible if our goal are not conflicting with each other, right? That is what social agents also do. They achieve their own goals, keeping in mind that whatever signals they are getting or whatever signals they want to transmit should not be disturbed, right? And the priorities are based on the program for which we have designed the overall system. For example, take the case of a firefighting robot. Here we have got three things. If we are having a room where a firefighting system is being installed, it consists of three basic intelligent agents which we have used. For example, we have used thermal sensor, we have used the intelligent uh, temperature sensor, the smoke sensor, and the sprinkler, which will sprinkle the water as and when required. So all these three agents are located at each and every corners of the room, and they are very well collaborating with each other. As soon as there is a temperature rise, or a smoke is there in the room, it will be automatically judged by the smoke sensor, and it will give the signal to the temperature signal to be alert, right? All these things are being working in a collaborative mode, or you can say in a social agent mode. Now, as the temperature or smoke is rising more and more and is beyond the control, or it is risen to a certain temperature which is beyond the control, they will give the signal to the sprinkler agent, and the actuator of the sprinkler will be getting activated and it will sprinkle. And one more thing, and if at all they are not able to quench the fire then and there, the fire will keep on spreading to the other part of the room. And as soon as they realize that the fire intensity is more, they will give the signal to the nearby set of these three agents, right, in a particular protocol language, right? And then it will be The two agents now will be acting for a particular goal. That goal is to extinguish the fire as soon as possible without loss of the property. So how they are controlling and communicating? They are controlling by the special language known as FIPA protocolic language, in which also known as agent communication language, in which they cooperate and collaborate with each other to achieve the common goal. Besides that, there are some other properties like mobility, veracity, benevolence, rationality, and learning and adaptation. Mobility means everywhere they can go. Veracity means their agent will not knowingly send the false information. If there is a malfunction only, then they will be sending the wrong information. Otherwise, they will not be sending the wrong information. Benevolence here means that I have told you earlier that there shouldn't be any conflicting goals. If I'm saying something, the other has to listen it till my communication is over, right? Based on the priorities which are being decided beforehand, before designing the system. That is known as benevolence. And rationality means the agent should behave for what they are designed for. They shouldn't have an irrational behavior in them, right? Then the last point, which is very, very important point, learning and adaptation. Learning is a continuous process in which we embed neural network or machine learning algorithms in certain agents such that they are in a continuous mode of learning, right? And as soon as they learn, they keep it in their knowledge base for further reference. If the same situation comes to them next time, they are well prepared of that, and they will take the information from the knowledge base, right? They will pick out from the knowledge base and then perform accordingly. That is known as learning or adaptation capability. For example, if I take the case of a child, say 3 to 4 years old, and who is unaware of the fire, gravity of the fire, there are chances that he may insert his hand in the fire, right, for the first time. And as soon as he gets burned, he will pull his hand away from the fire. And for the next time, he will not be going anywhere near to the fire. Why? It is because the mind has learned, that particular child has learned that fire is injurious to health. We should not go near to it, right? Or we should not play with it. So these are the kind of learning aspects which are to be embedded in the agents also, right? And day by day, these agents will be starting learning and keeping their knowledge or learning in form of a knowledge base. And as and when required, they will be retrieving them and performing the actions from the previous or past experience, like we humans do in the past language, right? Now, agents and objects. There is a still very, very confusion part in this particular area, right? That is the agents and objects. The difference: agents are autonomous. That is, they have their own capability of thinking, doing something very well because they are smart. That is, smartness here means they are flexible. Flexible is divided, Flexibility is divided into three basic parts. That is reactive, proactive, social, right? And lastly, the agents are active, right? They are continuously learning, while as objects are not at all continuously learning. They will do whatever they are programmed for, and they will not communicate with the other objects, right? Like unlike the intelligent agents. Agents are same, or you can say it's a same thing as an expert system which we have used in artificial intelligence. And the first expert system was developed known as MySim, which was able to detect the blood diseases and give the prescription accordingly from the knowledge base. So right there in the previous era, Mycin was developed as an intelligent agent, right? And based on that environment, based on the patient's condition, it was giving the prescription from the knowledge base which was stored in the knowledge base of the Mycin database. And likewise, we have certain real-time systems which work in a real-time mode. And AI is basically uh, the part of the intelligent agent. While as NetBot, we all have heard that various universities and all are taking, as soon as we log into their website, there is a chatbot opening up, right? What is that? It's an intelligent agent deciding, based on my traversing on the website and based on my questionnaires. If I question, say I choose to take master's program in artificial intelligence, then I type it on the chatbot, and based on my query, it will ask whether you want to do this. If I say yes, then it will divert. So based on that, question and answer sets are being saved in the intelligent database. They are also known as ontological information saving, right? Agents can work as an intentional systems. Intentional systems are what? Whose behavior can be predicted by the method of attributing belief desire, right? Whenever we program an intelligent agent, we are moving in the part known as belief, desire, and intention. We have to keep in mind about three things. First of all, there will be a belief, then based on that belief, there will be a desire and the intention to perform certain activity. Based on the desire, I'll be performing some activity based on the intention. For example, here we have a very suitable example of an agent which is taking the signals from the environment. These signals are nothing but sensors and actuators, right? Based on, I have told you earlier that based on the wind condition, my windows will close. Based on the cyclonic conditions, my windows will close. Based on the thunderstorm, my windows will close. So what are these? These are nothing but the sensors or actuators placed at my home location near my window. And as soon as there is a storm, what will it will do? It will sense and perform the action. And they are known as intelligent agents. And here we can see from the figure that from the environment, the sensor acts and the sensor then sends the signal to the actuators. Actuators are nothing but the physical activity performers, or you can say the electronic circuits which are capable of enhancing the signals received from the signal, because the sensor signals are very low potential. They will be upgrading it and then acting it accordingly in the form of some activity. And then what will happen? They will perform some certain action in return with the response or the perseverance from the environment. Whatever signal we receive from the environment are known as percepts, right? This will be frequently used when we are designing a system. So we have situated agents here. They are based on the actions and percepts. Situated means present everywhere. Present everywhere here means that ubiquitous environment. Ubiquitous means everywhere, anywhere, you can say. For example, I have told you an example of firefighting robot, which is located throughout the room. And based on the sensing capabilities, it will perform certain action. Right? If there is smoke, if there is a fire, there will be a temperature rise, and based on that, a sprinkler will be activated. So these are known as situated agents. Now, how they work? They work in plans and belief. Plans and belief And these plans and belief use the concept of BDI, belief, desire, and intention. Belief, desire, and intention perform, right? For example, you have to believe something, then you have a desire and intention to perform accordingly. Consider the case of, here we are dealing with the very interesting case of a soccer played by a robot, which is being programmed for a certain activity or conditions, right? Based on that, the robot goal is to put the ball in the goal post, right? We have seen here 4 conditions, right? And based on these 4 conditions, the robot will be doing certain activity. Now, these you can see that there are applicable if, plan body, plan, goal achieved is the template part of BDI. BDI is a language format in which applicable if, plan body, plan, goal achieved are the keywords, reserved keywords. Whenever we design a system, we have to use these keywords in the form of BDI, right? Now, first condition is robot at the ball and the goal is in front of him and it is unobstructed. There is no opponent in front of it. So what will be the second part? The bodily part, the physical structure of the robot. The robot has to stand in front of the goalpost. Since the ball is just right there in front of him, he has to just make a kick, which is just a straight kick directly going to the goalpost. Now, the second condition, there is robot and there is an obstruction and there is a goalpost. Robot cannot kick directly because there is an opponent who will be obstructing the goal. So what the robot should do? It should search for the better positioned teammate. Better positioned teammate. As soon as he finds the better positioned teammate, it directly passes on to the teammate and then the teammate will be in fact kicking the ball to the desired goal. That is what we have seen here. Plan body says identify the best teammate to score. Then what it will do? It will turn itself to the teammate. The teammate could be opposite to the goalpost, but never matter, right? It will be passing on and then the direct kick will be possible, right? The goal, we have seen that goal achieved in all the instances here. Goal achieved in all the instances is to score goal. Score goal, score goal. It will not change. It is the universal goal and it will not at all change in any of the circumstances. Now, the third condition, if the robot is not at the ball and knows the ball location, what we have to do? We have to see the ball location. The robot will be going to the ball and then kicking the ball directly facing the goalpost and then kicking the ball. So all these things are the basic parts of any intelligent systems. When we are designing an intelligent system, we have to find out what we have to do and how we are going to achieve it. And the main focus here is to follow the format of BDI, belief, desire, and intention, right? Where we have applicable if, plan body, plan, and goal as a template, and they will not change whatever the condition may be, right? Now we will see that agent execution cycle. Agent execution cycle we have seen earlier. The events are processed and updated and generated immediate actions. Similarly, as soon as the events are updated, the goals are also updated. Whatever goals up till now we have achieved will be kept aside and the reward for that will be given. And then the next stage will be given after that. You perform certain activity, you take the reward, move forward, right? That is what we are going to explain here in this particular situation. Then plan for the next cycle and then execute the next plan, right? That is known as Q model in the machine learning, Q modeling technique. You plan, perform action, take the reward or give the reward and then freeze it and plan for the next step. Take the action, get the reward, freeze the stage. This is how we move on in the queue modeling technique, or it is also known as agent execution cycle. Let's take a simple example. Here what we are going is, here we are seeing that I have to go to university, right? And there could be a condition. I have a car, I have a two-wheeler, but based on the environment, that is, if it is going to rain, then I have to take the necessary decision. The first instance, the plan one, walk to university, goal achieved is fixed, go to university. You will see that the goal achieved in each and every instances, is same. Go to university, right? If it is not raining, you can walk, very well you can walk. And train to university, it is raining, catch train, right? Tram to university, true, always applicable. The same situation, if it is raining, you can take a train or a bus or a tram, or a plan for the if it is raining, then you can do any or catch any of the public transport, right? So all these things we have seen here is dealing with the basic assets or basic, very basic concepts of the multi-agent systems, or you can say software agents. In the next lecture, we will be seeing the implementation part of the software agents using the concept of Prometheus